We are on number 55 for the function y equals log base 2 of x minus 2 plus 1. Determine the domain, range, and equation of asymptote, and then graph the function. All right, so let me write this down. Y equals log base 2 of x minus 2 plus 1. All right, so the domain is going to be restricted by the fact that you cannot take log of a negative. So x minus 2, in fact, you can't take log of 0 either. X minus 2 has to be strictly greater than 0. So x is going to have to be greater than 2. So your domain is that x is greater than 2. In other words, the interval from 2 to infinity, not including 2. The range, however, for a logarithm is all real numbers. And you'll see that when we graph it. That corresponds to the fact that the domain of the exponential is all real numbers, and the logarithm is the inverse. So the domain and range get switched. But this has a shift to the right 2 units. So the asymptote, the vertical asymptote that a logarithmic function has is going to be shifted to the right 2. And so we can go ahead and write that vertical asymptote is going to be the line x equals 2. It's on the edge of the domain. In fact, let's go ahead and sketch that. So x equals 2, right about there. All right, and then it's got to shift up 1. And then, if you remember, the logarithmic function with base 2 normally has a vertical asymptote at the y-axis and then an x-intercept of 1. And otherwise it looks kind of like this, kind of increasing, gets less and less steep as it goes on. So this one having a shift to the right 2, that point's going to move over here, and then up 1, it's actually going to be right there at 3, 1. And then the function is going to be curving up through that point and then down along its asymptote. So that's what it's going to look like. The x-intercept would be a good point to try to find. Obviously it does not have a y-intercept. In fact, you could see that it doesn't have a y-intercept because the y-intercept is always found by plugging x in, plugging 0 in for x, excuse me. If you try to take log base 2 of 0 minus 2, that is negative, and you can't take log base 2 of negative 2. That's asking what power of 2, that's the base, gives you negative 2. Like as if you could take 2 to some power and get negative 2, which of course can't happen because anytime you raise a positive number to any power, it's going to come out positive. 2 to the first is 2. 2 to the negative 1, remember, would be 1/2. So you can't get negative 2 from a power of 2. So that is undefined. And meanwhile, I have a cat here playing with a pen. So if you hear something funny in the background, that's Felix. Playing with a pen. All right, meanwhile, we need to look at what's the x-intercept. So there isn't a y-intercept. The x-intercept is when you set it equal to 0. So log base 2 of x minus 2 plus 1 equals 0. So if you solve that equation, you would first subtract 1 from both sides, and then rewrite it. The base is 2, the power is negative 1, and that's equal to x minus 2. All right, that's rewriting this logarithmic equation in exponential form. The base to the power equals x minus 2. You could also think of it in terms of exponentiating both sides. Since it's base 2, if you raise 2 to that power, that cancels out, leaving you with x minus 2, and then 2 to the negative 1 is over there. So that's 1/2. 2 to the negative 1 equals x minus 2, so x is 2.5. So that's your x-intercept, 2.5. So over here, our graph, that looks about right. Halfway between 2 and 3 is actually where it crosses the x-axis. Now, to do this on your calculator, you would have to use a change of base formula, at least on the older calculators. The change of base formula, if you remember, is that log, here, let me get where you can see this, log base b of x is log, say, base 10 of x divided by log base 10 of b. Or you could change it to log base e, ln of x, over ln of b. Those are the two logarithms that are on your calculator. Log base 10, the common log, and log base e, the natural log. So you can change that. So let's see, if we go up to this function, if we want to graph that on the calculator, you would want to rewrite it as log base 10 of x minus 2 divided by log base 10 of 2. That's that part, and then plus 1 to get that shift up. So you've got this log base 2 of something is log base 10 of that divided by log base 2. Log of 2, excuse me. Log base 10 of that divided by log base 10 of 2 plus 1. So that's how you could type it into this calculator. I'll show you the newer calculator actually has a different log, a different base that you can use. So this is, again, log of x minus 2 divided by log of 2. That's what changes it to base 2, or from base 2. And then plus 1, that shift. All right, and then graph. And there it is. And of course, the calculator can't draw the part that's almost vertical. It's graphing from left to right, and that's the first point it comes across. But really, we know that it continues on down infinitely close to its vertical asymptote. All right, on the newer calculators, they actually have a, let's see if I can get the glare from the ceiling fan off of there. They actually have another base. Let me clear out all this stuff I've got in here for some reason. All right, so they have, under the math menu, I believe it's just that first menu. You just scroll down to, yep, log base. So that actually pulls up something that looks like where you can put in log base 2 of x minus 2, which is kind of cool. And then plus 1, and then zoom standard. And you can see the same thing. Again, it still doesn't draw it quite right because it does continue on down along its vertical asymptote.